Hai, semua orang sihat ke?
Alhamdulillah sihat.
Alhamdulillah. Ada yang demam-demam ke? Ada yang dah kena jangkitan ke?
Susah nak tahu sekarang. Sebab
Ah,
sekarang banyak jenis 1 dengan 2 yang tak ada simptom.
betul-betul.
Cek dah ada dah.
Hai. Itulah harap-harap semua sihat lah kat rumah tu. Semua kat rumah ke?
Kerja.
Oh, kerja.
Ha, kerja sekarang.
Saya sihat, Prof.
Ya, Alhamdulillah.
Saya dah lengkap 2 vaksin, Prof.
Oh, dah lengkap 2 dah.
Dah.
Bagus, Alhamdulillah dah lengkap.
Itu mak saya tu. Dia saja dia tu.
Oh,
Dia saja ni.
Mak sihat, mak. Mak sihat, mak.
Alhamdulillah, Mama sihat di sini.
Tengok.
Alhamdulillah.
Nampak?
InsyaAllah,
Tengah
insyaAllah.
berniaga sambil buat DPR, anak sekolah kita kena buat DPR.
Terbaik, mak. Terbaik, mak. Terbaik.
Okay, insyaAllah.
InsyaAllah, insyaAllah.
Sebab anak pun terbaik, mak dia kena terbaik juga.
Tutup mic ah. Tutup mic.
Assalamualaikum. Boleh dengar rasa saya?
boleh. Assalamualaikum, Doktor.
Ah.
Okeylah. Kita dah seperti yang kita janjikan. Jam pun dah menunjukkan pukul 10.30. Okey. So saya mulakan lah. Sekali lagi saya nak ucapkan selamat datang ke program Introduction of Robot Operating System. Terlebih dahulu saya nak cakap Assalamualaikum dan selamat pagi yang dihormati Dr Muhammad Aizzat Zakaria selaku penceramah kita pada hari ini. Saudara Ricky Daniel selaku pengarah program dan saya Ain Tahirah, moderator anda dan juga semua peserta yang dikasihi sekalian. Okey, bagi memberkati program kita pada hari ini, saya ingin menjemput saudara Nabil bagi mengetahui bacaan doa. Silakan saudara Nabil.
Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Ya Allah, Engkau yang punya segala kepujian, Engkau lah yang berhak menerima segala pujian. Engkau lah yang berhak menerima segala kesyukuran. Engkau lah yang memiliki segala pemerintahan. Di tangan Engkau lah segala kebajikan. Kepada Engkau lah kembali segala urusan. Ya Allah, berkatilah pada hari ini iaitu program Introduction Operating System hingga awal dari akhirnya. Kami juga memohon perlindungan daripadamu dari segala perkara yang boleh mencacat celakan majlis kami dan dari segala perkara yang melalaikan kami dari berbuat taat kepadamu. Kepadamu juga kami serah segala urusan kami. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa sallam. Alhamdulillahirabbil alamin.
Amin, amin, ya rabbal alamin. Okey, terima kasih saudara Nabil atas bacaan doa itu tadi. Okay, sekali lagi saya nak peringatkan bagi sesiapa yang punya soalan, anda boleh ajukan di ruangan chatbot di bawah. Dan untuk siapa-siapa yang belum lagi check in, diminta untuk check in sekarang sebab link masa untuk check in tu akan tamat dalam masa setengah jam lagi, okey? Rugilah kalau tak check in, dah masuk. Kena check in. Okey. Baiklah, untuk pengetahuan semua, program Introduction of ROS ni adalah berkaitan dengan pengenalan pengoperasian sistem robotik di mana peserta akan diperkenalkan dengan tujuan penggunaan ROS, aplikasi ROS dalam penggunaan input, proses dan output, konsep teras ROS berserta persekitaran operasi ROS. Okey. Program ini dianjurkan oleh kelab UMPbot. Siapa yang tak kenal UMPbot tu? Okey. UMPbot ni adalah sebuah kelab robotik yang menawarkan ilmu kejuruteraan seperti mechanical, electrical dan pengaturcaraan. Bagi makluman semua, UMPbot telah mengadakan beberapa sesi program webinar yang terdiri daripada How to Build a Robot, T-Talk with Alumni, Back to Basic Workshop dan UMPbot juga telah menghantar wakil bagi menyertai pertandingan Robocon. Okay, so bagi anda yang ingin mengetahui lebih lanjut berkaitan dengan UMPbot, anda boleh lewati media sosial kami di Facebook, Instagram dan juga YouTube. Link kami sediakan di chatbot di bawah. Jadi jangan lupa follow kami. Okey, baiklah, kita berbalik kepada program kita. Sebelum saya menjemput penceramah kita, izinkan saya untuk memperkenalkan serba sedikit latar belakang beliau. Okey. Dr Muhammad Aizzat saya adalah merupakan pensyarah kanan di Universiti Malaysia Pahang. Beliau merupakan penyelidik di Innovative Manufacturing, Mechatronics and Sports Laboratory IMAMS. Beliau bekerja di bawah Sub-Research Cluster di Laboratory Intelligent Robotics and Vehicle Aero, di mana memberi tumpuan kepada pembangunan kenderaan pintar dan penyelidikan robot bergerak. Okay, tanpa kita melengahkan masa lagi, saya menjemput Dr. Aizzat bagi menyampaikan ilmu beliau. Doktor, silakan.
Okay, terima kasih Aina. Terima kasih dekat penganjur jugalah Ricky dan tim UMPbot. Saya pakai baju UMPbot ni nak promote. Saya nampak juga ada Dr. Hidayah, Asril, alumni pun ada ni. Oh, bagus korang. Okay. So kepada yang belum kenal saya lagi, saya introduce lah, nama saya Aizzat, pensyarah kanan bagi fakulti mekatronik lah dan ada yang campur sekali lah, bukan tim UMPbot dalam ni
Ada dengan pelajar UMP sekali.
Maksudnya semua pelajar UMP lah, okey. Okey, so saya akan share slide. Dr. Hidayah angkat tangan tu, ada nak tanya ke?
Tak, tersalah tekan. Minta maaf, iklan. sorry.
Sekejap saya share. Boleh nampak ke skrin yang saya share?
Boleh Doktor.
Okey, sekarang pukul 10.30. Okay, saya mungkin ambil dalam 1 jam setengah lah untuk present sikit. The language yang saya akan guna ni mungkin campur-campur lah. Kita tak formal sangat boleh. So today I would like to share the experience lah, lebih kepada experience dan saya guna ROS ni start tahun 2014 saya start belajar ROS 2014, sekarang dah around 4 to 5 years lah. Previously ROS is not that famous sebab tak berapa banyak dia punya capabilities yang dia boleh buat lah, dan recently due to the Industry 4.0 dan automation kind of thing, the ROS is started to become one of the robots operating system yang started to become trendings. So before that, kepada yang masih belum kenal saya, I would like to introduce myself first. My name is Aizzat, a senior lecturer from the Faculty of Manufacturing and Mechatronic Engineering Technology. I graduated from UTM on 2010. After that, I worked as engineer at Intel, and then I pursue my PhD study in autonomous vehicle development. So my PhD is on the trajectory tracking algorithm development at Universiti Technology Malaysia. And in 2012, I joined UMP as a senior lecturer, and I become a head of program for mechatronic until August. So just finished my term. So some very brief description about me is my research interest is on since 2012, where I started my PhD on the path planning trajectory tracking algorithm. some SLAM algorithm and more on the programming and software development. So I did a lot on the robotic and mechatronic. In fact, I teach mechatronic subject in my faculty. And I love to code, coding in my fashion. In fact, when I become a senior lecturer, I still code on a daily basis. And just to share with you guys, during our time, we have no Arduino. So everything we have to do it from scratch. There is a lot of time we need to spend. And some of the software that I developed for my research and for my PhD, I developed some trajectory tracking algorithm, scarf simulator, and some object tracking algorithm. So that's all, very brief overview on about me. So the objective for today's talk is about ROS, right? But the scope is really limited because the audience consists of the general background. So I try to use as simple as possible the talk. I try to avoid as low as possible the technical term. So because we want to give awareness on what is robotic operating system for UMP student, especially for the junior lah yang you boleh guna, and to expose the student on the importance of the programming skill. Maybe ada junior tahun 1, tahun 2, tahun 3 dah senior dah. So the importance of programming skill, why you need to do a programming, why you need, tak kisahlah macam mana, tapi the programming is very important, especially in the era of the IR 4.0. And the scope of ROS, of course, only 1 hour is not enough for you to become an expert in ROS. You need to do hands-on. Means that the longer time you spend the programming, the more expert you become. And ROS is just a middleware language. So means that ROS itself is not a programming language. You still need to learn the C++, the Python, the XML, HTML are required in order to use ROS. Means that in order to use ROS, you need to have several programming language. At least you need to have a basic. And because right now ROS is only support on the Linux operating system, so you need to learn Linux as well. As for now, but right now they are going for Windows and for Mac as well for ROS 2 development, but it's not yet stable. But anyhow, this is some scope for you if you want to learn ROS. So what I will present today is the awareness on the importance why we need a good robotic software. And after we talk good about the ROS, then we try to talk back about ROS. So what is so bad about ROS? So because we need to know that, for example, for certain application, is this software or ROS is possible to be used in our robotic application or is not suitable. So we need to understand what is good and what is bad. And some case study that I implement using robotic operating system. And this is a non-technical sharing. I will omit all the fancy technical term as minimal as possible. Okay, so we start with the simulation study. So why we need a simulation study? So for example, I try to relate with the UMPbot punya case lah. When you design the robot, normally, for example, last year, Robocon, you make a leg robot, betul? You make a leg robot, kemudian what you did is you simply buat design dalam CAD design, kemudian you simply terus masukkan dalam you fabricate the hardware. Dan kemudian ada design failure. Design failure, you keep 3D printing, you keep fabricating. But you don't know, you keep trying and error, tapi you punya masa adalah limited. Seperti during competition apa semua. Then you need to be at the lab for fabrication. And you don't know which method is the best. So that's why for me this is not a proper approach that you should go. So tapi ini yang kebanyakan student buat lah. Sepatutnya when we want to design something, the first step is we need to simulate. For example, you want to do a leg robot, right? You need to create dynamics or kinetics or kinematics of your robot first and say whether your design or construction is okay or not, and see how does it move when you try to move the robot. So that's why the simulation study is very important. So we need to know which is the best possible design so that we can implement it directly into our hardware. And we also see there are several AI and software programming. So we need to do a lot of simulation in order to create a real robot. For example, you only have, for example, UMP only give you 50K, right, to create a robot for your Robocon. But you cannot create hundreds prototypes from that one. But creating the prototype in the simulation costs you nothing, except your computer. So that's why we need to understand what is simulation study when we want to do something. And ROS is very good when we want to create this kind of physics study, to study the collision properties of our robots, and also the hardware modularity. For example, in Robocon, you are using Arduino. For example, in Robocon, you are using Arduino. You try to code your robot arm or robot leg. Kemudian, suddenly the processor is not good enough. You kena tambah satu lagi Arduino. Whereby your friend is developing a programming for the right leg of the robot. Your other friend is developing a programming for the left leg of the robot. So, bila you nak buat programming tu, adakah dua Arduino ni boleh synchronize ke tak in term of signal timing? In terms of data transmission. So this kind of thing, when we want to expand, for example, we have one Arduino, we want to expand it into several Arduino, how do we synchronize the data? Kan? Macam mana kita nak synchronize the data? Or how do we make the data is have some standard so that when I want to use for other application, I want to use for other hardware, I can still reuse my same code. So with this term is we call it hardware modularity, means that we can employ an extension to whatever we are doing right now without doing everything from scratch again. So means that I have this code and I can simply transfer it to my another applications. And the next is software modularity. So right now when we talk about the hardware modularity, means that you can expand your hardware without much trouble. I don't say much trouble. Actually, in education, you have much trouble because you need to debug a lot of things. But when everything is running, you understand everything, it becomes smooth already. And the next is the software modularity. Means that if I have one software code, for example, I have the trajectory tracking algorithm code that I developed, right? And I want to increase it by having, for example, right now, my tracking algorithm, I'm using encoder. And I'm trying to put the vision capability so that I can have a better tracking algorithm. So I can simply take from what my friends developed, and then I can simply include it in my own programming without disturbing my own programming, because the way what ROS is doing is, instead of we put everything in one single programming language, for example, you have one app. Instead of we put everything in one app, we have multiple programming. You imagine like a block of Lego, that if I need this shape of Lego, I can simply take this shape, I plug in with whatever I'm building right now. So if I want to have this module, I will just take and plug and play. It's not plug and play, but you need to do something lah. But this is the idea. So compared to for example, compared to when I give you an Arduino example, because I know that students use Arduino a lot in your project. Compared to using Arduino as your main controller, you put everything in your Arduino, and if you want to do a lot of programming, you include some interrupt function, but you don't include some threading or whatever kind of thing, and it becomes the software is become lagging because of the limitation of the hardware itself. You cannot do a parallel processing, but if we have a software modularity, we can do this kind of thing without any problem. And when we talk about ROS, normally we talk about platform components. So for example, you see as an example in the screen, what is PC and what is smartphone, and what do these two hardware have in common. So as you can see that both have operating system. They have hardware abstraction layer, and we have a software. And these two, they provide an app, they provide services and application. For example, the Google Meet that we are doing. So they are sharing on the same approach, right? So if we try to put it this way, we have our laptop, our PC, we call it a PC, a personal computer. So if you see here, the PC start with the hardware. So it means that you have the hardware configuration of your PC, the CPU, the RAM, and then you have your Windows, your operating system. You have a Windows, you have a Linux, and after that we have application. We have Google Drive, we have Microsoft Word. So this is what we call application. And the last is user. So user is ours, the one that we are using. For example, you are using an app, a Google Meet app right now. So we are the users. And when we talk about personal phone, personal smartphone lah, kalau kita compare dengan the previous phone, zaman Nokia yang lama tu, dia tak ada this architecture. But the modern smartphone, they have the architecture, they have the hardware. Kan, macam you ada Android, you start comparing berapa banyak RAM you punya phone compared to your phone RAM. So kita ada hardware. So the same with PC. Dan kita pun ada OS. Kalau Android dia pakai Android OS lah. Kalau iPhone dia pakai iOS. Sebelum ni kita ada Symbian, kita ada Windows punya OS. So the same operating system. And we have an app yang kita boleh download daripada Apple Store dengan Android Store, Google Play. Dan macam mana dengan robot? So kalau you punya robot sekarang ni, UMPbot, saya ambil example sebab saya tahu, sebab saya pernah tengok macam mana you buat. If you are UMPbot, you ada robot, kan? Kemudian straightly your robot go to Arduino. Betul? So you tak ada operating system for your robot. So means that you tak ada the way you control macam mana frekuensi you nak transmit the data is depending on how good your C programming. And you need to program everything from scratch. Tapi kalau when we talk about ROS is an operating system for the robot itself. Means that macam operating system kita buat sekarang ni. Apa yang for example I take example of the PC sebab you boleh imagine gaming, right? Kalau we use like a video conference, our CPU, our graphic, maybe they use internal graphic only. Tapi when you start to open a lot of graphical like software, CAD design, your PC started to switch from the internal graphic into the graphic card. So that you have a better processing unit. But you don't know when your PC is using a graphic card, right? Everything is managed by the operating system. So the same thing with ROS. So for example, if we don't have operating system, you are coding your code using Arduino. So if I ask you what is the frequency of your data loop of your encoder reading of your Arduino, so maybe most of you cannot answer because you don't count based on the timer, you don't count the sampling time. But if we have ROS, for example, we want to set a certain sampling rate for the tensor transmission, everything is managed by the ROS programming itself. So we just set some value, so everything is managed. So we can focus on our main algorithm that we want to develop for robot application. But at the back layer, the way they process, the way the trading kind of things is managed by the operating system itself. So that is why ROS is called robot operating system. Is not a programming language, but is an operating system like the operating system Windows or your iOS. And also we have apps. Apps something like macam you punya application, so something kita nak throw the data. For example, kalau kita macam yang setengah familiar with MATLAB kan, kita nak plot graph. So kita ada apps yang macam dalam ROS juga where we want to we are able to plot graph or not. So we have the same thing. So means that if we make the same ecosystem macam computer and phone, means that you have the same architecture like a normal embedded or hardware operating system. So this is what we call it a platform component of the robot operating system. And robot software platform. So ROS also they are provide a robot software platform that include tools that are used to develop the robot application program such as hardware access layer. So that we have some tool that is used to communicate with your programming level to the hardware level. So maybe some of the things that already being preloaded in the ROS program, and low-level device control, recognition, and SLAM. So although we don't have an official SLAM algorithm, but ROS provide some tool for you to visualize some data so that we can focus on our algorithm SLAM development, and when we throw out the data, we can visualize it so that we know that whether our algorithm works correctly or not, and some tool for the package management, libraries, and debugging and development tools. And so the robot software platform also, the ROS is trying to separate between the hardware level and the software level. Means that if we are using, for example, if we are using Arduino directly plugged to the robot, means that the user that is programming the Arduino, the C code, need to understand the hardware. Means that you need to understand in order to communicate with the motor, you need to give a 5 volt supply to your driver, and you need to plug 24 volt to your motor, so that you need to understand the motor driver kind of things. But let's say we have people from computer science background that have limited knowledge on the hardware level. So, but they still want to do a programming. So the way ROS split the architecture in the robotic operating system is that if I have a software algorithm, I can directly develop my software without understanding too much on the hardware. But we have a framework that we want to integrate this thing. We don't have many things that we need to configure. So we have this kind of robot software framework for ROS. And if you see here, ROS is just one of the robotic operating system. Actually, we have many. Instead of ROS, they have Japanese Open Robotic Technology Middleware, Oral COS, and Korean. But ROS is one of the operating system that is quite famous among researchers, among robotic engineers, because we have a community-driven support. And so we do have this kind of thing you can use if you want to try. But for today, we only focus on ROS. Okay, the question is, why should we use a robot software platform? So the answer is because we can reduce the development time. As I said, you are developing a robot, we need to do a lot of testing of the controller, a lot of testing of our robot before we fabricate it. So we try to reduce the development time, and we can convert it. For example, I have my previous OpenCV programming image processing, and this is my old software that I developed, for example. But if I want to integrate it into my new system, my new ROS system, I can just add library file, ROS library file, and I can make my system become compatible with the ROS system by following certain ROS protocol. So means that whenever I plug it into certain ROS protocol, this robot is able to communicate with other application inside the ROS system. So this is why we need the advantage of ROS, because it can reduce the development time. And second is the usability of the program. Like a Lego, right? You take one, we want to use, for example, we are using on the big robot arm, the image processing algorithm. So we can just take this one, put it into the mobile robot by only a few code modification. So we can simply reuse, what we call it, reuse our code. And the ROS is using what we call it a communication-based program. Means that the way we talk on ROS, the way we pass the data on ROS system is based on the IP address. TCP/IP. We call it a TCP/IP protocol. So the TCP/IP protocol is like we talk in the internet, how you transmit data through the internet by IP address. Means that, in other words, your computer become like a device with IP address that you can use to talk with other device with IP address on the same network or the internet network. So means that the concept of ROS is like Internet of Things, right? When you want to do like Internet of Things, you ada, for example, you ada LoRa punya modul, IoT LoRa tu, bila you set up the LoRa, you need to set up your Wi-Fi, you need to set up your IP address. ROS also communicate on the same thing, but on the bigger ecosystem compared to macam kalau you ada Bluetooth low energy punya IoT device, kalau you ada, dia adalah the on the embedded system only, dia tak ada operating system. But if we use ROS, kita boleh communicate dengan the same concept using the ROS communication based program. And next is the need is for robotic software platform is the support of the development tool. So we have a 2D visualization tool, we have a 3D simulator, we have a debugging tool for the ROS. And we also can record data during experiment and replay the data whenever it's necessary to recreate the exact experiment environment. So that when we log the data, whenever we want to play back the data, we can load it, play it like we record it in the actual environment, like in the actual experimental. Maksudnya you ada grafik, you boleh tengok macam mana data tu berubah. So it helps us in developing algorithm for our robots. And the next is the active community. Means that we have support from the company that is supporting the ROS package development, and we also have some researchers, some people that is developing a standard package. Of course, they won't be everything, but the framework of the package will be there. Sebagai contoh, you nak buat 3D design, you tak perlu develop the 3D design software itself. You guna package open source yang ada, kemudian you top up di situ, improve the package. So we don't have to develop everything from scratch. So there are a lot of things already pre-configured inside the robot operating system, but we need to understand how to use it. And the most important part is your algorithm itself, so that you can focus your own algorithm instead of developing the framework, instead of developing the ground level of your system. And the next one is the formation of the ecosystem. So means that if you see maybe in Malaysia, this thing is not happening in exponential yet, but in Europe's countries, they started to develop, for example, the hardware developer is ROS compatible, and they have some ROS team, some software can plug with the ROS system, so that everything they have the same protocol. So that like in the your laptop, right? You have a USB, right? You have USB port, you have USB-C port. So if we are talking on the same protocol, so everyone will be focusing on the same system, same architecture. So it's easier for us to develop an application that is be able to maintain the code for several years. So this is the advantage of the ROS. And the robot field is moving on the same track as in the smartphone. Macam kita punya smartphone, kita ada ROS operating system. Macam kalau kita ada Windows 7, Windows 10, kemudian kita nak ada nanti Windows 11. Kalau Android, kita ada macam-macam lah, Android 10, 11. So the ROS is the same. Kita ada beberapa ROS version yang akan keep upgrading. Sama macam software macam Microsoft, dia ada develop robotic developer studio. So dia ada juga dia punya upgrade version lah setiap version tu. And various robot software platform are appearing, but it's hard to conclude which one is better. Sebab kalau kita tengok MATLAB 2021 punya version pun, they started to provide the ROS support, tapi They ada develop their own punya method untuk MATLAB. For example, MATLAB dia ada develop dia punya sistem dia di mana you can reuse your Python code and convert it into the MATLAB code. So this kind of thing. So there are many software, for example, but ROS is one of the software that is open source, means that we don't have a license issue to use this kind of operating system inside our robot. If we use, for example, a commercial software like a MATLAB and LabVIEW, we need to pay for the license fee. And in order to get it started with ROS, so what we can say is ROS is an open source, flexible software framework for programming of the robot. And the robotics application that understand ROS, we can develop the software without see whether our hardware is compatible or not. And the hardware engineer that is working with ROS can work without worrying too much on the software level. So this means that everyone has their own role, so that we can simply split the tasks. And the core of the ROS framework is the message passing middleware, which process can communicate and exchange data with each other, even when they are running from different machines. So that's why I said ROS is like IoT device, whereby if we have multiple devices, you can communicate each other, so that you have your local ecosystem, you have a server, you have IP address running on each devices, and we can set our message to be synchronous message passing or asynchronous message passing. So this is difficult if we are using, for example, just Arduino alone. You want to pass the data to other system. If we want to set asynchronous handshake or synchronous handshake, is hard to configure, but with ROS is much more easier when we want to pass the data to our robot. And the software in ROS, we call it as packages. So it offers good modularity and distributivity. So it means that we can plug and play and we reuse for another project. So what we can say is ROS is a community-driven project supported by developers worldwide. So in short, ROS is the combination of a plumbing or communication tools, capability and ecosystem. So kalau you tengok dekat sini, this is our ROS system. So ROS system consists of how we develop our package, how we organize our package. So we have a node level, we call this as plumbing, and combination with tool, we have a developer that is developing tools that we can use to manage all of our package. And we have some predefined standard algorithm. For example, you have PID, right? You have PID, you can use a PID, but of course you need to configure something. But we have some very base framework to use in our system. And of course, the ecosystem that is supported by researcher and developer around the world. So with this ecosystem, so it creates a very big system that is become a generalized robotics operating system. And each ROS, as I said previously, we have like Windows, you have a version, Windows 7, Windows 8, Windows 10. So ROS also we have distribution. So you can refer to the link below so that you can see that there are a lot of distribution that is being configured for ROS. And because ROS is running on the Linux also they have their own version. So we call it a Linux distribution. So each distribution maintain a set of stable version. Means that one version, for example, we are using a Fedora Linux 18 version. So it support for 5 years until end of life. We call it end of life distribution. And normally compared to Windows, for example, kalau you tengok macam Windows, you ada Windows 10. But if you have an application for Windows 7, you can simply have a compatible layer version for each of the ROS version. But for ROS is a bit different, and Linux is a bit different. Because if you have a different Linux version, it's not like the same you upgrade, you simply can use in the next version because of the different kernel used in the Linux distribution. So the ROS is tied to the specific Linux distribution that you can refer better on this link. And ROS is an open source meta operating system. We will see what is meta operating system. It provides tools, as we mentioned. And before we go with what is meta operating system, we need to understand first the operating system that use ROS. So in this talk, normally ROS is being supported by using a Linux operating system. We do have ROS for Windows, but at the moment it is not. It's in the trial phases. So maybe in the future, in the like 2 years in the future, you can use a ROS for Windows. So of course, if you want to strictly use ROS, you need to understand what is Linux. So Linux is the operating system like your Windows that is around in 90s, and Linux actually is everywhere. It's in your phone, in your car. Some car you use Linux, some embedded system, for example, your Raspberry Pi, right? Raspberry Pi, you use Linux as well. If you use NVIDIA, Jetson, they also use Linux. So basically, Linux is everywhere, but for general audience, like people from non-technical background, maybe this is your first time heard what is Linux actually. So it's like your Windows operating system, but the different with Linux, they have a different Linux version. For example, the famous one is Ubuntu, and they have some terminology on the Linux that is you need to understand, like you understand the Windows, but this terminology is being used a lot by developer. And compared to Windows, for example, Windows you only have, for example, you have Windows 10, so everyone have a Windows 10, and everyone need to use Windows 10 at the same time. Similar with a Mac OS. So if you use Mac OS Sierra, so this, for example, that the latest one, so means that this is the version. But for Linux is different. Because Linux is an operating system that is open source, people or developer around the world will modify the Linux version to suit the application. So for example, we have Linux for robotics application. We have Linux for hackers. We have Linux for IT server. We have Linux for IoT. For example, Raspberry Pi, they have a light version of Linux, Raspberry OS. And if you see here, for example, on the slide here, we have some example, Linux Mint, Manjaro, Debian, Ubuntu, Antigua, Solus, and there are a lot of things of the Linux version. And it's quite confusing. You cannot simply upgrade. For example, I'm using Ubuntu. I cannot simply upgrade it suddenly to use Social Linux. So I need to wipe my laptop, and I need to install the latest or the new operating system. It's like a new system. You cannot simply like you right click update your Windows. So this is Linux. So because why Linux like this is because the philosophy of the Linux is that one is open source. Everyone can modify their own operating system. In fact, Google also, they have their own Linux system. And if you see here, for example, the Debian Linux, right? The Debian Linux is developed in 90s. So it's open source. And this operating system is being developed further by a commercial company. They call it Canonical. So this company developed what we call it a Ubuntu. So the Ubuntu is using a Debian framework. So this is a commercial company, means that it's not a free, but this company is giving a free version to all people, except people will pay if they need to get the support from the Canonical company. And we have the Ubuntu development until here. We also have a Debian Linux development until here. So you can see that we have a Debian operating system, Linux operating system, and we also have a Ubuntu. Similar with a Social Linux. So you can see that it developed based on the Slackware and it evolved. And same with the Red Hat. Red Hat Linux is normally used by the hacker for penetration testing. And is being taken by a company Red Hat Enterprise, and they expand further into a Fedora Linux. So you can see how the operating system is being evolved because of its open source and supported by community. And which one is the best operating system is depend on application. So there is no this one is better than this one. So it depends on your operating system, on your application. So what is meta operating system? So operating system, as I explained just now, we use a Linux. For example, Linux means Ubuntu is one of the flavor. So when I call it Linux, so means that it may be not Ubuntu, maybe different name. But if you have a version, Linux mean or Ubuntu, Fedora, or this is what we call it a Linux distribution or flavor. And similar with Mac, you have a different version. And for smartphone, you have Android, iOS. And is ROS a new operating system for robot? It's not new, but we can say that ROS is a meta operating system. What is meta operating system? So when we call a meta operating system, it's not a conventional operating system that you see in Windows, Linux, and Android. But a meta operating system is an operating system that runs on the existing operating system. Is that we have a very big operating system at the outside of our robot. For example, you have Linux or you have Windows, but inside the window itself, you have ROS operating system. This is what we call it as a meta operating system. And if you see here, what meta operating system is doing is the ROS is provided for developing, managing, and providing application package for various purposes. So you have a robot, you have an algorithm, you have a sensor, and this is your real operating system. Right? You have your Windows or Linux or Android, and meta operating system is providing the inside operating system of your main operating system, so that it can provide a communication level with your robot, your application, or your sensor. So this is what ROS is all about. And because, as I said, ROS is driven by data communication protocol. So ROS data communication is supported not only by one operating system, but also by multiple operating system, hardware and program, making it highly suitable for robot development where various hardware are combined. Because sometimes we have hardware developed on Mac, we have hardware, for example, you use on Arduino, some hardware developed on the Intel platform. So because of data communication in ROS, so for example, I have Ubuntu, I make it compatible with ROS, I can simply communicate with the other ROS network. So means that we create a very big networking communication network in our robotic system. So for example, you are using the Intel Realsen sensor running on Windows, for example, but our robot running on Linux, because both to have the ROS inside, so you can simply passing the data. It's like one whole same communication protocol. So this is what ROS is all about. And the objective of ROS is to build the environment that allows robotic software development to collaborate on a global level. Means that on a global level, the way we see from the ROS perspective is what kind of data we transmit, what kind of data format or data type that we transmit. We don't see your computer as your computer is running on Windows, your computer running on Mac. No, we only see the data passing, so that you can have a good data passing algorithm, a good package management, so that you can distribute and you can have some repository for that developer to contribute and improve your code. And also, when I say the ROS is an operating system and not a programming language, means that you can use whatever programming language that suit to your application. For example, some researchers, they like to use MATLAB, for example, but they need to communicate with a robot, so they can use a MATLAB plug in with a ROS tool, so you can communicate with your robot. Or some need to develop using Python for machine learning. So we can also put some header for ROS and you communicate, you make your system is in the ROS network. So means that it's very flexible to develop using whatever the preferred programming language that you prefer for your robotic application. And you can see here, these are the some tools. Maybe you can see some technical. I'm not going to go in detail for each one, but what I'm going to say is we have a lot of layer for ROS that is you can configure it. For example, we have some hardware interface layer for some driver, common driver for ROS, common driver for GPS, so that when we communicate, we can simply configure the driver. And we have some software development tool, RVs, RQT, for if you want to develop some app for your system, and some simulation, gazebo, stage ROS, and some client layer. So if this is your algorithm programming, for example, you want to use C++, but you want to communicate with the ROS, so we use some header, we call it a ROS CPP. You want to use Python, you want to communicate with ROS, we use ROSPy, similar with, for example, Java. And we have some robotics toolbox that we can configure, move it some, there's a lot of toolbox here. When you go deeper, so you can understand what all of this. But what I can say is we have some framework of the operating system that is ready for us to use to configure whenever we need it. So this is the component that is inside ROS. So when we talk about the ecosystem inside ROS, means that we have our robot, we have our meta operating system, and this is your programming algorithm. For example, you are developing your robot for Robocon, this is where your algorithm is doing. And you have other team. So your team can develop a robot hardware layer, so that when you plug, so you can simply communicate between each other. And some numbers, so they have 5,000 packages and it's growing more. And this is what is inside of the ecosystem. And some pre-configured robot like a Turtlebot is already configured with ROS. You can just plug and play. But if you need a specific robot application, of course, you need to develop your own driver, your own sensor architecture for the robot. But for education, they have some several robots that is ready for you to learn ROS. So we have several ROS version. So the label based on the letter of each release in the alphabetical order. So we have Box Turtle, Sea Turtle, Diamondback. This is a version like a Linux version. So until 2020, we have until L, M, N, and until, the last one will be N. So before they go with the ROS tool, so that you can use for your Windows operating system. So of course, when we talk about this one, you can see here we have a lot of version already. And when we talk about Linux as well, you have a lot of version. The question is which version is the best and what kind of version you want to use for your application. So this is a tricky question actually, because it depends on your application. For example, you need a light application, so you need to use a Ubuntu made version for light application. So you need the letters, you cannot use Ubuntu 40.04, maybe you need to use 80 or 20.04. So, but the disadvantage in using the latest version is some package is not stable yet in the early development phase. So it become buggy because it's an open source system. But if we use a previous version, it is more stable, but the disadvantage of the previous version is the support is no longer provided by the community. So it depends on your skill level. If you are just a beginner, for example, I recommend you use a previous version, for example, 16.04 or 80.04, so that everything is stable. But if you are an advanced user, you can use a latest version so that you can experiment, you can contribute to the latest package development on the open source community. So this is the history of ROS, originally developed in 2007 at the Stanford AI. Right now, the main package development is managed by OS RF, means the Open Source Robotic Foundation Company. So this is the database, the server to download the package management is managed by this company. Today, many robot universities and companies use and become a de facto standard for robots programming. And this is some ROS philosophy. Peer-to-peer, individual program communicate over a defined API. We call this as a ROS message and ROS service. So it means that you develop one node, we call it node, and this node is transmitting some message and distributed, like I explained, you can expand on multiple computer, multi-language. So you can use whatever language that suit you, that you comfortable, and lightweight, standalone libraries that are wrapped around with a thin ROS layer. Means that, like some, for example, if we are installing MATLAB applications, right, you can see that the full MATLAB package size is about 30 gigs, and it's very big. But when we want to develop an application, robotic application, we want to keep the cost as minimal as possible, but achieving our objective. So that's why the ROS package is like a puzzle. So whenever we need a bigger package, so the puzzle will be bigger. Whenever your system is just a simple system, the puzzle will be smaller. So means that we can say that this is a lightweight application, and of course it's free and open source. So most of the software is open source and free to use, so that you can reuse the code. And because of the ROS is communication between node or process, and we need to configure a server. We call this as a master. So sometimes we call it a ROS core, so that you have one master that is managing. So the master is responsible for managing your process. For example, this is your application, right? So this is your application. So the application will register itself as a client to your overall network. And when it is connected in the same network, you can simply talking, for example, your application number 1 to the application number 2. You can do a data passing, you can develop your algorithm. And each application, for example, node 1 is organized in package, so that we call this as node 1 is one package. So node 2 is another package, depending on our configuration of the ROS. So the link here you can see to know detail. This is just overview only. And node we call it a package, we call it a node, communicate over a topic. So means that we have some topics communication. We can publish, means that you can transmit the data, the message, we can publish the message, we call it a publish, or we can subscribe. You can subscribe from other network. For example, I want to get the information of the node 2, I can subscribe this data, and the topic is a name for stream of message. So the data type of normally is transmitted over a topic layer. So there are some terminology here. I don't want to go detail here, but this is normally how the command line that we use to view the status of our system. And also we have some terminology when we want to pass the message. We call it a ROS message, which is the ROS message is a data structure that is defining the type of a topic. So it comprises of a nested structure of integer, float. So if you see here, the layer is actually based on the C++ data type. So that's why you have integer, float, boolean, string, dan yang lain-lain. Then when we have this kind of data type, actually ROS also they have their own data type, but the base of the data type is based on the C++ data type. That's why when I said earlier, you need to understand C or C++ in order for you to understand ROS better. So the topic here, when we want to submit the data here, we need to understand what type of the data. So we call it what type of message. So this one we declare it in the ROS message format data type. So this is the example. For example, we want to pass certain message, and the message inside the ROS we call it, for example, geometry message, whereby if you can see that inside the geometry message you have some like a C++ data type float. So we declare as YZ, or you have a sensor data, right? You have a sensor data. So say this is the ROS message type. We call it a sensor message image.message. And inside here, this is the detail based on the C++. And also you also have a geometry message. We call it some geometry message. Inside here, you can see that we have some position of the robot and orientation of the robot. So if you see from this geometry message, it's actually based on the fundamental of robotic. So in order for you to understand your robot's movement, you need to understand C++ and you need to have some robotic fundamentals. So is that you can see this thing. And also we have a concept of nodes previously, a concept of topic, a concept of message in ROS, and also we have a concept of nodlet. So nodlet is like how do we want to optimize our ROS architecture. So how do we, for example, you have a very large application, how do we design our node to run multiple nodes in a single process, which is not has a separate threading, so that it don't wait for other data, so it can run in parallel. So we have this kind of optimization in the ROS system. Okay, so when I talk about general overview, ROS message, ROS topic, ROS server, right? This is good, but next is we want to talk what is the bad thing about ROS. Not everything is good. So you see that ROS is good in terms of managing, especially if you have a bigger package. But of course, whenever we have a lot of things, and at the same time we introduce a complexity of the system setting. So we need to understand everything. You need to understand the hardware. But once you configure everything correctly, then you just can forget it because everything is running. Second is because it's open source and every package is managed independently by developers. So one wrong package update, if you manage to update your package wrongly, will ruin the whole system dependency. But this is rarely happen. But if this is happen, then you are in trouble. Open software, although it's free, most of them is buggy. It's not polished as in the commercial software. You need some programming skills to fix the bugs. Every ROS version will require a specific version of the dependency. Will be cost headache for system upgrade for mass scale production. So that's why some of the new thing about ROS, they introduce a concept of Docker, like a virtual machine, so to eliminate this issue. And also because of this problem and some deployment problem, that's why the developer around the world is actively developing what you call it a ROS2. ROS2 is a new architecture, maybe a bit different from what I presented, but the ROS2 is trying to eliminate the problem of project deployment, but right now it's still in active development stage. It's not yet stable yet, with a lot of package to be added in few years. Learning ROS is a slow learning curve. It's not as easy as you learn one single thing. You need to learn a lot of things. You need to have several skills and knowledge about robotic and programming. For example, you need to have robotic knowledge, dynamic, what is the kinematic of the robot, what is the transformation matrix. You need to have a programming knowledge, C++, Python, and operating system knowledge, Linux compilation, debugging skill. So you don't give up easily if you fail a system error in your system. Patient, structural thinking, because if you have a very large package, and visual thinking, because in ROS you need to do a lot of, with a line of code, you need to imagine everything in your head, and money maybe for the hardware. And this is bad, broken and incompatible hardware. You buy the hardware, suddenly your hardware not support the driver kind of thing. So this is bad thing, not everything is good, but you need to understand, but normally the good thing is better compared to the bad thing. That's why many people use it. Okay, so this is a very basic introduction on the ROS. So I think that's all from me. So maybe some of you still junior, tapi kalau you ada plan untuk in this robotic kind of field, we from research team on the vehicle intelligent vehicle system are doing this kind of research lah. Yang tapi kita perlukan orang yang ada this kind of knowledge lah, especially on ROS lah. That's why it's important for you. I think in the future industry 4.0 also pun dekat company luar pun they started to see people with C++, with machine learning punya knowledge. Kepada junior yang masuk di UMP ni, you ada lagi katakan 3 tahun, 4 tahun dekat UMP, I think is for you to grab the opportunity untuk belajar banyak, join macam tim-tim robotik, UMPbot ke apa tu, benda ni akan bagi you exposure. Sebab the thing about programming, the thing about this kind of thing yang you tengok dalam video ni is about hands-on. The more time you spend doing things, walaupun benda tu simple ataupun ada, the more you learn. Sebab ada benda yang kita hanya boleh experience bila kita buat salah. So that is from me on ROS introduction. I think that's all. I give back to moderator Ain.
Alhamdulillah, terima kasih doktor. Terima kasih atas penyampaian yang cukup baiklah, sangat-sangat menarik saya rasa. Ilmu yang dikongsikan tu sangatlah berguna. Jadi walaupun tajuk kita ni introduction, tapi saya rasa lebih daripada introduction lah doktor cover tadi.
Itu baru intro tu.
Okay. Jadi kita nak buka untuk sesi Q&A. Sekiranya ada para peserta yang ingin menanyakan soalan, boleh tekan button raise hand. Saya nampak tadi Hasanul Akia dah raise hand. Ada apa-apa nak tanya? Hello Hasanul, ada nak tanya ke? Okey, tak apa. Kalau macam tu saya saya baca soalan di chatbot yang mereka send tadi, doktor.
Boleh. Baca saya jawabkan.
Okay. Hasanul Akia, dia tanya, is the ROS needed to be code from scratch or it is available open source to use and edit?
Okay, dia macam ni. Dia punya konsep dia, sebagai contoh kita nak transmit data kan. Kita nak transmit data, hantar data, baca data. Contohnya kita nak transmit image processing kan. Kita nak hantar image, baca image. Benda tu banyak example di internet. Sangat-sangat banyak. But if you want to, for example, you nak buat classification on specific topic. You nak buat, sebagai contoh, saya tengah develop satu image recognition untuk palette detection kan. The example macam kita nak baca data, kita nak buat guna OpenCV, integrate dengan ROS tu ada. Tapi for specific application, macam untuk Robocon kan, kita nak develop, detect benda ni, kita nak 100% tak ada. Tapi the basis for you to go further tu kat situ banyak example. So dia normally that is how open source punya community lah. Dia akan bagi example yang basic-basic, tapi the advance tu normally kita tak akan release lah sebab ada beberapa macam confidential yang macam dia orang pun tak akan publish benda tu lah. Tapi untuk you start, you transmit data, benda tu banyak, sangat banyak example. Okay, ada dua lagi soalan daripada Hasan doktor. Satu lagi, does that mean the ROS depend on Linux version? Yes, dependent on Linux version. Maksudnya kalau contohnya you pakai melodic, for example Ubuntu melodic, you kena pakai 18.04. Kalau you pakai kinetic, you kena pakai 16.04. You tak boleh pakai 16.04 kepada melodic. So sangat dependent. So kalau you expert, you boleh ambil kod yang sedia ada, you boleh compile balik. Tapi kalau you just started to learn, I recommend you to start with the previous Linux version yang dah stable, sebab apa, dekat example dekat internet tu banyak, then you boleh play around with example yang ada dekat internet lah sebab dia open source. But if you become more expert, you baru pergi latest version, compile your own code from the source file. So is yes, the answer.
Okay. Okay, satu lagi. Is the message and instruction set from other language?
Yang mana? Daripada siapa ni?
Hasanul. Masih lagi.
Tak, is apa? Cross dependent. Boleh ulang kali tak? Saya tak nampak lah soalan dia.
Is the message.
Okay, is the message and instruction set from other language? No. Message ni dia macam kalau dalam C++ kita declare variable kan. You declare variable, kemudian you declare variable ni float ke double ke, kemudian barulah you boleh guna variable tu, betul? Dia sama dalam ROS, tapi dalam ROS kita panggil dia message. Dalam message dia ada variables. Kemudian kita hantar dekat application lain tu, kita hantar message. That is data communication. So the message is not instruction set. The message is like data type that we use to send. Kalau instruction set, you still need to program it using C++ or Python or any other language lah.
Okay.
Okay, ada lagi soalan daripada sini? Banyaknya soalan tengok tepi ni. Saya baca boleh
Boleh.
Pada Asril lah.
Asril.
ROS is middleware and consists of multiple nodes that contain data. Based on your experience, what is the suggestion to make GUI or control or display the back-end data? Okay, untuk GUI untuk GUI kita ada banyak lah, depending on you nak guna untuk platform apa. Katakan you nak guna untuk cross platform. Kalau cross platform normally kita guna RQT lah. Sebab RQT ni dia boleh run on Windows, dia boleh run on Linux, in fact dekat Mac pun dia boleh run. Kalau you nak buat specific platform macam on Windows, kita boleh develop GUI pakai .NET. Dalam .NET tu kita pakai ROS wrapper. Kalau you nak pakai dalam MATLAB pun dia ada MATLAB programming, nama dia GUIDE, Guide, MATLAB Designer Tools. Di situ pun you boleh buat GUI, kemudian you wrap dengan ROS punya wrapper. So it depending and you nak implement dekat mana. Kalau you punya application sebagai contoh dekat dalam Raspberry Pi kan, you tak boleh pakai yang heavy, you kena pakai yang the light GUI punya tu. Mungkin you boleh guna Python punya GUI. So it depends kat mana you nak implement.
Okay, hi Dr.
Okay, Asril.
Okay, application saya more on industrial application, industrial deployment. So because all this data, ROS data is technical punya things lah. Then as a user, dia tak boleh tengok benda-benda ni, so dia tak akan faham. Contohnya operator dekat kilang-kilang, so bila nak tengok data tu dia mesti kena user friendly lah. So how to compress, combine all this data, back-end data to display as easy for operator to see lah. Like that kind of.
Okay, you boleh guna, saya cadangkan kalau macam tu you boleh guna ada dua lah, sama ada you nak, kalau dia you nak dia cross platform in the future, you boleh guna RQT lah. RQT dia boleh cross platform, ataupun satu lagi you boleh guna web base. Cuma masalah dengan web base ni dia ada beberapa benda yang tak boleh buat lah melalui web base bila kita nak communicate. Kalau you nak, tapi kekurangan RQT ni bila you implement sebagai contoh dekat Windows ke apa, you kena verify balik yang the programming tu works on that particular platform. Tapi the code dia boleh cross lah, maksudnya tak banyak modification. Kalau web base, you program sekali dekat mana pun you boleh buat, tapi web base dia tak banyak kompleks punya GUI yang boleh buat dengan web base tu, dia ada limitation lah. So kalau setakat simple you guna web base pun boleh.
Okay, faham.
Okay.
Terima kasih.
Okay, sama-sama. Osman dia tanya different between ROS 1 and ROS 2. Okay. ROS 1 ni dia, kalau you tengok ROS 1 tadi saya dah present, kita based on notes. Notes in kita kena ada satu server, kita call ROS core or ROS master. Tapi ROS 2 ni dia kalau you tengok tadi kita ada satu ROS master. Kalau ROS master tu destroy, maksudnya server kita tutup server. Ibarat you pergi dekat google.com tu tiba-tiba you tak dapat search kan. Sebab apa? Server Google tu tak accessible. Sama konsep dengan ROS 1. You tutup server, you punya node yang bawah tu semua akan destroy. Tapi kalau ROS 2 dia bukannya server dependent. Each node dia ada dia punya macam satu app yang boleh connect kepada server dia sendiri. You tutup satu server, node lain masih boleh hidup. So itu main advantage of the ROS 2 lah over ROS 1. Tapi dia masih belum stabil lagi lah saya kata. Okey, harapnya menjawab soalan. Ada lagi?
Ada lagi doktor. Ni daripada soalan daripada kelab UMPbot tu.
Kelab. Can ROS communicate between different programming language? Can communicate between C++, as the publisher and Python? Boleh. In fact, benda ni pun memang commonly used lah. Bukan setakat C++ dan Python ni, you nak guna language apa pun boleh. Yang penting dia punya message data type mestilah you kena declare dulu apa benda yang you faham dengan message data type. So the programming language is not a concern in ROS. So the most important is you understand what is the message data type that you're going to pass to other node or applications.
Ada lagi doktor daripada Zul Bazli. Soalan dia atas pada asli tadi.
For IP communication can connect multiple, boleh, tak ada masalah. For IP memang default communication is IP communication, boleh connect multiple device, tak ada masalah.
Next, soalan daripada Aiman Hakimi.
Mana maksud kalau kami baru nak belajar pasal kena tahu dulu basic robotik and programming. Yes, saya recommend sebab kalau you belajar sebagai contoh lah, you buat pakai C++ atau you pakai .NET lah. Saya bagi tahu contohnya you buat programming .NET communication pakai Windows. Dalam tu dia ada IDE yang you tersalah tulis ke dia akan buat autocorrect kan. Kalau Python pun you ada Python IDE, you ada PyCharm, dia boleh debug you punya code. Tapi bila you nak guna ROS ni, you imagine you tak ada a general set of IDE. You ada satu Visual Studio Code yang di mana compilation tu melalui terminal. Dia tak ada user friendly yang macam dia tolong highlight code ni, error ni kat mana, sebab apa. So bila you ada masalah dekat debugging dekat situ, kalau you punya basic sebagai contoh, you nak declare variable pun you lupa letak semicolon. Dan you punya masalah kat programming, tapi disebabkan you terus buat dengan ROS, kan, you terus buat dengan ROS, you tak boleh tengok sama adakah problem tu sebab compilation of your own programming ataupun configuration of your ROS system. So saya punya cadangan sebelum you masuk kat ROS tu, at least you ada basic pasal C, pasal C++, you boleh guna, you understand Arduino macam mana nak guna, you pernah buat sikit pasal GUI, kemudian barulah you masuk. Kalau tak, nanti you akan lost apa yang sebenarnya yang you buat. Sebab dalam tu dia tak ada, sebagai contoh, dalam programming you ada buat pasal pointer, pasal header file. Dalam ROS kita banyak pakai header file untuk panggil different function. So benda tu kena ada knowledge. Kalau tak, nanti bila compilation you tak faham apa benda yang you buat. Okay?
Okey. Harap-harap menjawab ya semua soalan yang ditanya tu. Okey. Dalam chatbot itu saja soalan. Jadi ada siapa-siapa lagi ke yang ingin bertanya?
Hello. Hai, Doktor.
Hai, Asrul. Apa tak nampak?
Okay. Saya nak tanya berkenaan dengan industri punya problem lah. So saya rasa Doktor lagi banyak pengalaman dalam LiDAR punya sensor. Sebab dalam LiDAR kita ada dua kan, 2D dengan 3D. So Doktor lebih familiar dengan 3D punya LiDAR. So mostly dekat industri problem dia adalah contohnya dalam production dia banyak shiny surface, shiny material, so that will affect the LiDAR punya performance lah. So dia doktor dalam 3D punya application pernah terjadi benda ni ataupun memang macam mana overcome problem?
Okay, kita overcome problem ni kita jangan rely on satu sensor je. Sebab tu kita ada sensor fusion. Maksudnya kalau LiDAR you fail kan, contohnya kalau LiDAR you fail, you nak trust dekat measurement mana. Sebab you ada odometer, sebab dia depend on apa benda. Kalau you nak buat localization, you nak detect kat mana robot you berada, you tak boleh rely on single sensor. Sebab sebagai contoh macam you kata tadi, kalau kita guna LiDAR saja, kita nak track, kita nak baca dia movement of positioning based on the initial base, macam mana frame tu berubah setiap frame. Kalau sebagai contoh dia berpusing laju, you dah salah dah measurement you sebab initial bacaan tu dah salah. So kita boleh fuse dengan beberapa sensor lah macam IMU. Tapi kalau your application macam on surface scanning kan, kita nak scanning surface, kita mungkin guna LiDAR, you kata reflection. So jangan guna LiDAR, guna kamera ke. So dia akan, maksudnya kalau satu bacaan tu tak trust, you kena ada satu sensor yang complement. Sebagai contoh, kita pakai GPS untuk tracking contoh kan. Kalau GPS tu masuk dalam terowong, you tak boleh rely on GPS sensor. You kena rely on odometer dengan IMU sensor. So you kena ada kita panggil sebagai fault check lah. Kalau benda ni tak trust, dia akan automatically switch dia punya trust punya level tu dekat sensor lain. Itu kita buat macam tu lah. Sebab tu tadi kalau saya share tadi, you tengok bila kita baca pusing kan, kita rely on odometer dengan IMU, kita pusing UMP tu kita tak dapat correct loop kan, dia ada terkeluar daripada map tu. Tapi bila kita trust different level depending on kita punya sensor reading, kita boleh dapat perfect loop, perfect mapping. Itu saya kata kita kena tengok dekat mana application tu.
Okay, sebab sekarang ni contohnya mobile robot lah. Mobile robot kita ada dua sensor, so macam doktor kata kita tak boleh rely on one sensor LiDAR. So sekarang ni mobile robot tu dia ada dua sensor, dia ada LiDAR dan dia ada kamera.
Okay.
Then both data simultaneously running lah. So 3D camera bukan macam kamera biasa lah, dia akan point cloud semua. Then still problem, dia punya robot tu nak function lah. So sometimes dia interrupt data, sometimes dia tiba-tiba stop sebab dia tak dapat read data, sebab dia combine these two data. Macam dia
you pakai on the same processor ke you pakai different processor?
Same processor.
This is the problem. Sebab kalau contohnya you kata you pakai point cloud, point cloud itself is a very big, katakan 3D camera lah, saya ambil assume dia pakai 3D camera. 3D camera dia ada image scanning. Kata you pakai interior scan ke?
Ya.
You pakai interior scan 3D ke?
Bukan.
Okay, katakan you pakai interior scan, you ada point cloud tu punya format dengan image punya format. So dekat situ data dia besar. Then you kena kira berapa sampling time. Kemudian kalau you punya data transmission tu pun dah besar, tiba-tiba you campur balik dengan algoritma lain, you tak boleh dapat perfect synchronize. Dia akan ada data lagging lah kita panggil. Sama ada you reduce the sampling time of the scanning, ataupun kalau you pakai ROS, you pakai komputer lain lah. Komputer lain buat different algorithm, kemudian dia akan keep comparing benda tu. Dan satu lagi, kalau macam saya kata tadi, kalau you pakai kamera, you boleh guna landmark based recognition lah untuk reset the positioning error.
Okay, terima kasih.
Mama.
Okay, terima kasih untuk soalan Asri. Siapa-siapa lagi ada yang nak bertanya ke berkongsi ke pengalaman dengan ROS? Okey, jika tak ada, saya rasa yang tadi tu adalah akhir lah kita punya soalannya, Doktor.
Okey boleh
Boleh semua?
So harapnya saya beri pendedahan lah sikit dalam masa tak lama ni.
Amin. Okey. So saya nak ucapkan terima kasih doktor. Terima kasih semua atas soalan-soalan dan juga perkongsian yang anda berikan. Jadi sebelum tu kami nak menjemput untuk semua peserta buka kamera sebab kita nak adakan sesi bergambar. Jangan malu-malu, jangan segan. Buka kamera, kita nak post dalam UMPbot punya Facebook, Instagram.
Boleh jadi student balik.
Buka.
Boleh jadi student boleh lah. Banyak muka saya tak pernah jumpa ni sebab COVID ni.
Dah, ada lagi ke yang tak buka kamera?
Mana Aiman ni? Tak buka kamera lagi. Hasanul.
Kamera rosak. Troubleshooting kan.
Aduh. Siapa kena rosak?
Okay, dah ready ke semua? Okay, senyum.
Okay, senyum semua, nampak gigi.
Okay, dah.
Okay, terima kasih.
Okay, terima kasih untuk kerjasama semua. Okay, jadi kita dah pun sampai ke penghujung program kita hari ni. Jadi sebelum bersurai, saya nak minta untuk semua peserta isi check out dulu. Link diberikan di ruangan chatbot di bawah. Okay, isi dulu sebelum keluar.
Okay, saya leave dulu
Okay, boleh doktor, boleh.
Okay.
Terima kasih doktor.
Assalamualaikum.
Assalamualaikum.
Okay. Yang lain sebelum leave tu isi dulu check out.
Okey.
Dan pun
Yang
tak check out.
Mana robot? Nak tengok robot ni.
Robot ada dekat lab. Okay. Sebelum tu, sambil-sambil anda mengisi check out tu, saya nak beri sedikit hebahan lah, iaitu UMPbot akan mengadakan program selanjutnya yang bertajuk Data Science and Artificial Intelligence yang mana akan membincangkan konsep dan kepentingan data science and artificial intelligence dalam industri. Data science dan artificial intelligence ni saya rasa sangat meluaslah digunakan dalam bidang teknologi sekarang ni.
Okey.
Jadi untuk anda tahu dengan lebih lanjut pasal data science dan artificial intelligence ni, apa tunggu lagi? Join lah kan? Jadi untuk memudahkan anda dapat maklumat, capai sebarang maklumat, jadi silalah follow kami di Facebook dan Instagram, iaitu link diberikan di ruangan chatbot di bawah. Jadi saya berharap semua dapat ilmu yang berguna lah hari ini dan jelas matlamat kita, iaitu kita tahu tentang apa itu ROS. Jadi sekali lagi terima kasih daripada saya kepada semua. Semoga setiap daripada kita mendapat ilmu yang bermanfaat, berguna untuk masa yang akan datang. Dan ingat, sesungguhnya orang yang berusaha untuk menuntut ilmu itu adalah orang yang berjaya. So sekian saja daripada saya. Maaf atas segala kekurangan dan juga terkasar bahasa ke, tersilap bicara ke. Jadi Assalamualaikum dan salam sejahtera bagi sesiapa yang belum selesai bagi sesiapa yang dah selesai check out, anda boleh live sekarang. Terima kasih. Assalamualaikum.
Terima kasih guys. Terima kasih. Assalamualaikum. Jumpa lagi next
Assalamualaikum.
program.
Terima kasih.
Jumpa lagi.
Kesihatan semua ya.
Ya, insyaAllah.
Terima kasih alumni. Terima kasih UMPbot.
Sama-sama. Terima kasih join.
Nak tanya
Boleh. Okay.
Ain Tahira Ricky ni senior student lah ke lecturer?
Kami senior.
Lecturer. Student.
Kami student.
Okay. Sama dengan Ikmal tu
Sama.
Okay. Saya pada baru masuk. Okay,
So tak masuk UMP lagi lah.
Belum menghirup udara lagi.
Belum menghidup udara UMP.
Saya depan insyaAllah, saya depan.
Rasanya dah terima dah surat ni.
Oh.
Okay lah. Nanti apa-apa boleh tanya kan?
Boleh.
Boleh.
Okay, itu sajalah. Assalamualaikum.
Salam, terima kasih.
Waalaikumsalam.
Bye semua. Bye. Bye Puva. Okay, saya kira.
Bye semua. Terima kasih ya.
Bye, sama-sama. Terima kasih juga.
Ni saya nak tanya ni. Yang tadi punya program tu macam mana nak masuk?
Oh, yang data science tu. Okay.
Tu
Silakan.
tu nanti kami inilah hantar semula maklumat tu dekat grup WhatsApp.
Kalau nak senang, nanti awak boleh follow IG kami. Dekat situ kami akan buat hebahan.
Okay. Thank you.
Sama.
Bye-bye.
Bye-bye.